Hello, I am Jackson Shibley, and this is the final design presentation for Spacecraft Design 2. This project focuses on the exploration of Europa. Europa is one of Jupiter's moons, with a global subsurface ocean suspected to be beneath its icy shell. The mission is to measure the thickness and structure of the ice layers to support drilling and submersible deployment. This is to be done by using my instrument, a ground-penetrating radar. The apparatus is comprised of a rolling cart, with transmit and receive antennas attached to the front and rear respectively. The transmit antenna will send out a pulse, which propagates through the objects before eventually being reflected back to the receiving antenna. The time delay between send and receive pulses informs us on the depth of reflection. Meanwhile, the frequency that is reflected informs us of the composition of what is reflected by. There's a camshaft attached to the rear wheel, which will transmit a pulse once per revolution. These pulses are then stitched together to form a two-dimensional map of what is below the radar. Here's how the system works. The microprocessor first sends a signal to the digital to analog converter using the I2C bus. The digital to analog converter then outputs a varying 0 to 5 volt signal. This varying 0 to 5 volt signal is used to control the voltage controlled oscillator, which then oscillates into the desired radio frequency band of 300 to 500 MHz. The radio frequency transmitting signal is then sent through a power amplifier, amplifying the signal before passing through the transmitting antenna. On the receiving side of the circuit, the received signal first enters a low noise amplifier before passing through the radio frequency mixer. After it passes through the radio frequency mixer, it goes over to this chip here, which is a series of two op amps. The first op amp is set up as a low-pass filter. This low-pass filter filters out any frequency above 500 MHz. After that, it passes through the high-pass filter, which then filters out anything below 300 MHz. The signal is then sent back to the microprocessor, which is digitized by a 14-bit analog to digital converter. Here is a test of the GPR. Underneath my coffee table, I have one air void, a tub of water, and another air void. The goal is for the ground-penetrating radar to detect the bowl of water. Let's test it out.